Hello! Today, I'll be walking you through Privitty Edge, a solution that adds end-to-end encryption to your existing IoT gateways, edge nodes, and MEC deployments. Privitty Edge is a lightweight daemon that runs directly on your edge devices. It integrates seamlessly with SCADA systems, MES platforms, and custom applications, enabling encrypted data transmission across your infrastructure. Here's how the architecture works. At your edge gateway, where your application is already running, you deploy a Privitty Edge container. This container listens on port 7200 and establishes end-to-end encryption with a designated peer, which can be another edge node, a fog device, or a cloud endpoint. Communication between peers is handled through Privitty Relay, a federated relay server. You can self-host your own instance or use the existing ones we provide. On top of encryption, Privitty Edge also enforces access control. You can define exactly who can view or download data, set time-bound access windows, and use the built-in revoke feature, which instantly renders data inaccessible even if it has already been downloaded by the peer. The Privitty Edge container is available on Docker Hub as well as the GitHub container registry. Here are the two ways to run it, the minimalistic version for quick testing and the production configuration, which is what we recommend. When sending sensor data, reports, or other files to a peer, those files need to be accessible to the container. The recommended approach is to bind mount your data or documents folder into the container at startup, and that's exactly what we'll do in this demo. For interacting with the container, you have two options, curl API calls or Docker exec commands. Both are valid. Curl is ideal for scripting and integration with external systems, while Docker exec is convenient for direct container interaction. We'll use a mix of both today. In this demo, we have three components: an IoT gateway node where the Privitty Edge container will run, a secure viewer, and a physical operator device representing a real-world peer rather than a second container. This gives a more realistic picture of how a field operator would interact with the gateway. Let's start by setting up the operator. The operator is now online. I have the Privitty Edge image already pulled from Docker Hub. Now let's start the container. This command specifies the container name, sets the device name, we'll call it factory-gateway-01, provides the license and mounts the local volume into the container as mentioned in the documentation. The container runs on port 7200, but it can be any port as you configure, and since it's built in Rust, will enable info-level logging for visibility. The container is created and running. Let's verify its health status. Confirmed, it's healthy and ready. From now on, I will call gateway instead of container for better clarity. Now let's link this gateway to the operator's mobile app so the operator can view activity and exchange files. I've set the base curl command as a shell environment variable to avoid typing full curl commands each time. Checking connectivity. The status code 4000 confirms the gateway is connected. To connect with the peer, we generate an invite code from the gateway and share it with the operator. The operator can either scan the QR code generated from this link or paste the URL directly. Either method works. Both sides are now connected. You can see the confirmation. End-to-end encryption and access control are established. Let's verify the connection status from the gateway side using a Docker exec command this time. The gateway shows it's connected to the operator. And the session ID is chat12. A quick note on terminology. Internally, we refer to peer sessions as chats because the system supports connections to multiple parties simultaneously, not just one-to-one. Let's test basic messaging. Sending a message from the operator to the gateway. Hello device, can you keep sending me data? And it's been delivered to the gateway's device. We can view the received message on the gateway side and you can see it's exactly what the operator sent. The gateway can reply as well. The operator receives the message instantly, end-to-end encrypted both ways. File transfer now for the primary use case. Files can range from small sensor snapshots to large aggregated reports. Sending a file to chat12, here we specify the access duration, set to 30 minutes, and configure permissions. In this case, we'll allow viewing but not downloading. The peer has received the file. Opening it on the operator's device, you can see the access data. Sent by factory-gateway-01. Received at this timestamp. Accessible until 1:40, forwardable, but download is disabled, exactly as configured. Now let's send a file in the other direction, from the operator to the gateway, this time with a 24-hour access window. Viewing on the gateway. On a gateway device, you typically won't have a graphical interface. If you need to inspect received data directly on the terminal, you can use the built-in message viewer. Here we're viewing message 25 and message 29. We also support rendering PNG files in the terminal. The fidelity is limited by the terminal renderer, but it works. The message ID in this case is 33. There are many more commands and capabilities available. One key feature we haven't shown today is the revoke function, which lets you instantly invalidate access to any previously shared file, regardless of whether it's been downloaded. That wraps up the Privitty Edge demo. Happy to answer any questions.